In the long winter nights of Scandinavia, light was not decorative. It was survival infrastructure. Vikings did not have the luxury of smoky, unstable flames filling enclosed halls and ship cabins. A poorly burning lamp meant damaged lungs, ruined food stores, and a constant fire risk. Yet archaeological evidence and experimental reconstructions show that Viking tar lamps produced a surprisingly clean, steady light, often cleaner than many modern kerosene lamps used today. This is not a romantic exaggeration. It's actually the result of fuel chemistry, airflow control, and lamp design refined through generations of daily use, rather than industrial convenience. Why Vikings treated lighting as an indoor survival problem, not an outdoor flame. Most modern fuel lamps are designed with portability in mind and, are often used in ventilated spaces. Viking lamps were primarily indoor tools. They burned in longhouses with low ceilings, limited airflow, and people sleeping nearby. This forced Viking craftsmen to solve smoke, soot, and odour at the source. The goal was not brightness at all costs, but sustained, breathable light. That priority shaped both the fuel and the lamp itself. So, what Viking tar actually was, and why it behaved differently from kerosene, is really quite fascinating. Viking tar was produced through the slow pyrolysis of pine wood in low oxygen conditions. This careful process drove off volatile compounds while preserving heavier, more stable hydrocarbons. The result was a thick, resin-rich substance with a high flash point and a slow burn rate. Unlike kerosene, which is a refined petroleum distillate containing a wide range of volatile fractions, pine tar burns progressively rather than explosively. This controlled combustion, you see, is the foundation of its cleaner flame. Now, why does slower vaporization produce a cleaner burn? Well, kerosene lamps rely on rapid fuel vaporization at the wick. When conditions are imperfect, which, let's be honest, they often are in cold, damp, or poorly ventilated environments, incomplete combustion occurs. This produces soot and sharp fumes. Viking tar vaporizes slowly and unevenly, feeding the flame at a measured rate. The flame remains smaller and more stable, which dramatically reduces particulate output. Less vaporized fuel escaping combustion means less smoke. How Viking lamp design amplified fuel efficiency. Most Viking lamps were shallow stone or clay bowls with a narrow lip that pinched the wick. This limited oxygen exposure and prevented excess fuel from flooding the flame. The wick itself was often twisted wool or plant fibre that absorbed tar gradually rather than saturating instantly. Modern kerosene lamps prioritize adjustability and brightness, often allowing too much fuel to reach the flame. Viking lamps restricted the burn by design, enforcing efficiency regardless of user input. It's a bit surprising. Why was soot accumulation lower, even though the fuel was so much thicker? It seems counterintuitive that a thick, sticky fuel could actually burn cleaner than a more refined liquid. But here's the thing. Soot production depends more on combustion stability than on fuel viscosity. Tar lamps, for example, maintained a consistent flame temperature and shape, and that's what really made the difference. Now, kerosene lamps. They frequently fluctuate because of drafts changes in wick height and even fuel pooling. And, well, each of those little fluctuations creates soot spikes. Viking tar lamps, on the other hand, avoided this by minimizing variables. The lamp was simple, and that simplicity actually stabilized combustion. So, how did Vikings use maintenance to preserve clean light? Well, clean burning didn't mean they could just neglect the lamp. Viking households routinely trimmed wicks, removed charred fibre, and stirred the tar to prevent crust formation. These steps only took a few moments, but they really did preserve airflow and kept the fuel consistent. These days, modern lamp users, often just crank up the brightness, which actually pushes kerosene lamps into these really inefficient burn zones. The Viking practice, on the other hand, was all about maintaining the system rather than simply overpowering it. So, how does this knowledge apply to, modern off-grid lighting? For today's survivalists, or even historians who are experimenting with alternative fuels, the real lesson isn't to ditch kerosene altogether, but rather to truly understand how combustion behaves. By using thicker fuels, reducing how much wick is exposed, and honestly prioritizing flame stability over just pure brightness, you can dramatically cut down on smoke. Interestingly, when folks try replicating Viking-style shallow lamps with modern materials, they often end up with cleaner burns, even when using contemporary fuels. Industrial refinement, didn't automatically lead to better indoor lighting. Refinement was really about optimizing kerosene for transport and mass production, not for the health of people using it in enclosed spaces. Over time, the assumption of ventilation just became built into modern lamp design. Viking lighting, on the other hand, assumed confinement and actually adapted to it. This difference in underlying assumptions, it helps explain why older systems can sometimes outperform newer ones when they're faced with the same constraints. So, why were Viking tar lamps safer over long periods? Tar lamps were less prone to flare-ups because the fuel itself resisted sudden ignition. Kerosene vapour, on the other hand, can ignite really rapidly if it's overheated or accidentally spilled. Viking tar required sustained heat to burn, which, gave users more control and a bit more warning when conditions started to deteriorate. In wooden structures packed with people, this really mattered. So, why did this system disappear despite its clear advantages? Tar production was, honestly, pretty labour-intensive and really quite region-specific. Petroleum fuels, on the other hand, scaled globally and, required much less local knowledge. As lighting moved outdoors and into industrial settings, the benefits of tar lamps just, mattered less. Back then, efficiency was measured in lumens, not lung health. The Viking solution faded away not because it failed, but simply because, priorities changed. But why does this forgotten technology still deserve our attention? For historians, Viking tar lamps reveal a surprisingly sophisticated understanding of fuel behaviour and indoor air quality, centuries before modern science even addressed it. And for modern off-grid users, they serve as a reminder that cleaner light doesn't always come from higher refinement, but from, controlled combustion and thoughtful design. The Viking tar lamp, honestly, stands as proof that ancient solutions were often shaped by much harsher realities than our own. These lamps were engineered not for convenience, but for survival inside enclosed spaces, night after night. If uncovering this kind of overlooked practical history matters to you, well, Relic Logic is exactly where you belong. Subscribe to the channel for more deep explorations into ancient technologies that still outperform modern assumptions. And share this episode with anyone who believes progress sometimes means, remembering what we forgot.